In this last video of the section, we're going to talk about something that will be important to us anytime we're doing proofs that involve any kind of number systems. So in particular, we're going to talk about closure properties for different number systems. So first, we're going to think back to some of our early mathematical experiences where closure issues indirectly presented themselves, although you wouldn't have used this language back then. We're going to define what closure means on a given number system for a given operation. All right, so let's think back to your early mathematics days, back when you were doing arithmetic. At some point, when you were first learning subtraction, you were not allowed to subtract a larger number from a smaller number. That simply was not allowed. It didn't make sense according to the context in which you were learning subtraction. However, later on, when you learned about negative numbers, it turns out you could subtract any numbers that you wanted. And similarly, when you were first learning division, you were allowed to compute division problems like 6 divided by 2 to get 3, but you were not allowed to do 3 divided by 2 because you wouldn't get a whole number. However, later on, when you learned about fractions and rational numbers, you could divide any numbers that you wanted. Well, you couldn't divide by 0, but everything else you could divide. So here's a model for what's happening here, and I call it the teacher's permission model for closure. We say a number system is closed under an operation if your teacher allows you to use the operation all the time on the number system. Now, of course, this involves two things. First of all, you need to do only the things, you can do only the things you have permission to do. But the teacher has some responsibilities as well. The teacher, it's important to communicate what number system you are using. And let me explain what I mean by that. So let's think about the old days with subtraction, right? So there, when you were only allowed to take a larger number and subtract from it a smaller number, implicitly your number system was actually the set of natural numbers, right? And what can you do with a set of natural numbers? Well, if you add any two natural numbers, what happens is you always get another natural number as a result. So what was happening was anytime you were adding natural numbers, which for you was the whole world of numbers, you always got another natural number, which was again part of your world. However, under that number system, you can't always subtract two natural numbers to get another natural number. If you try to subtract 2 minus 5, that didn't make sense in that context, not because it never makes sense, but because it doesn't make sense if you're only talking about natural numbers. So subtraction is not always allowed. So we'd say in this particular context, the set of natural numbers is closed under addition. However, since you can't always subtract any two numbers that you want, it's not closed under subtraction. So once we got to the newer days, right, when we were allowed to subtract whatever we want, then we were really actually talking about the number system, the integers, the set of integers. Okay. If you have two integers, right, so that one's going to be closed under addition, because if you have two integers and add them together, you always get another integer. Again, if your world of numbers is the set of integers, you add two integers, you're still within the world that you understand. However, it turns out with the integers, subtraction is also a closure operation. It's closed. The integers are closed under subtraction as well, because again, if you take any two integers and you subtract them, you're still in your world of integers. You still get an integer. All right, so this hopefully will help us get to a formal definition of what closure means. So suppose n is any number system. Now the number systems we were talking about were the natural numbers or the integers, but you have a ton of number systems that you've looked at, like the real numbers, the rational numbers, the complex numbers, things like that. So if n is any number system, and suppose O is an operation on n, and you could think of O as an addition, subtraction, multiplication, division, some kind of arithmetic, or any other operation as well. So as I mentioned, arithmetic counts as an operation, but even things like you have a number and the operation is take its additive inverse, get its negative. Or you have a number, take its reciprocal, right? Any kind of operation on a number is allowed here. We say that n is closed under that operation O if we can use the operation O on any numbers in n. In other words, if n is your number system, in other words, the whole world of numbers that you're looking at, and O is an operation on that, you could always use O no matter what number system and no matter what number in n that you choose. All right, so now that we've had a good discussion on this one, I think you're ready to work on the activities. The PDF file is called Closure Properties of Number Systems, and it's included with this video.